Let us talk about this problem. We are given an array of three types of elements. We need to sort this array. This problem is asked in many different ways, and here I have written three common ways. The first is you are given an array of zeros, ones and twos. You need to sort this array, which means all the zeros should come first, then all the ones, then all the twos. The next form is three-way partitioning. You are given an array. You need to partition the array around a pivot, and there can be multiple occurrences of this pivot, and all occurrences of this pivot should come together. For example, if you see this array and pivot is 2, what happens here is all occurrences of 2 come together, then all the smaller elements than 2 on the left side, all the greater elements than 2 on the right side. See, the order of these elements which are smaller can be anything, and the order of elements which are greater can be any order. But all 2's should come together, and all the smaller than 2 should come on the left side, all the greater than 2 should come on the right side. And this is the third form. Here we are given an array and we are given a range. Instead of single pivot, we are given a range. What we want is all the elements which are smaller than the smaller value of this range, smaller than 5, they should go to the left. Then all the elements which are in this range 5 to 10 should come. Then all the elements which are greater than 10 should come. So if you see this array, the elements smaller than 5, only one element 3, so first 3 comes. Then all the elements which are in range like 5, 6, 9, 10, and these elements may appear in any order, right? Order is not important here. And then all the greater elements in range 20 and 40. So these are three common ways this problem is asked. Now please pause this video and try to think of a solution to solve the problem. Let us first talk about a naive solution to solve the problem. The idea is to use an auxiliary array. We create a temporary array of size n. Now what we do is we first traverse through our input array, consider all zeros and put all zeros in the temporary array at the first positions, right? So after the first loop, our temporary array is going to have 2 zeros because there are 2 zeros in the input array, and remaining elements we don't care, right? So this is what happens after the first loop, and in the first loop we are running a loop from 0 to n minus 1. We check if it is 0. If it is 0, we put it in the temporary array and we increment the index of temporary array. Please note that this variable I is being shared by all the loops 1, 2, 3, right? In the fourth loop, we are simply copying the temporary array back to the original array. So in the second loop, we are copying all the ones, right? If it is 1, we put it in the temporary array and we increment the index in temporary array. In the third loop, we are putting 2's. So we put into the temporary array and we increment index. And at the end, our temporary array has all the required order elements, right? All the zeros first, then all ones and then 2's. So what we do at the end is we simply copy the temporary array back to our original array. So our original array becomes 0, 0, 1, 1, 1 and 2. Now time complexity of the solution is theta n, auxiliary space is theta n, but this solution requires 4 traversals. So please pause this video now and try to think of a solution that works in theta n time, requires theta 1 auxiliary space and does only one traversal of our input array. Let us now talk about the efficient solution. The algorithm that we are going to discuss is a standard algorithm called Dutch National Flag algorithm. And this algorithm is simply a variation of Hoover's partition. See, in the normal Hoover's partition, what we were doing, we were partitioning the array around a pivot. And what we were having is all the smaller or equal to elements on the left side, all the greater equal to elements on the right side. Here, what we want is, we want an extension. What we want, all the pivots should come together, right? For example, in this problem, if we want to sort this array, we can consider 1 as a pivot, right? And we want all the occurrences of 1 to come together and all the smaller elements to go on the left side. So what all smaller elements we have? We have only zeros, right? So all the zeros will go to the left side and all the greater elements to on the right side. So what greater elements we have? We have only 2's, right? So if I modify the Hoover's partition algorithm in such a way that all the pivot elements are coming together, then I am able to sort this array of zeros, ones and 2's. Now please pause this video. Take a look at the Hoover's algorithm and try to extend the algorithm to solve this particular problem. Here is the idea of this Dutch National Flag algorithm. We are going to maintain 4 sections in our array. The section from 0 to low minus 1 is going to contain all zeros. The section from low to mid minus 1 is going to contain all ones. The section from mid to high is unknown. These are the elements we are currently processing. So what are we going to run? We are going to run a loop for mid, right? And we are going to bring mid and high toward each other, right? And when they cross each other, then we say we are done. We have traversed every element, right? And high is going to be set up in such a way that elements after our high are all 2's, right? Now, how do we initialize these variables? See, here we are guaranteeing about before low, so we will have low as 0. So there is nothing before low, so there is no guarantee required. And we are going to initialize high as n minus 1. So there is nothing after high, so our guarantee is still valid. And we are going to initialize mid also as 0. We are guaranteeing about elements before mid, right? So that guarantee is also valid, right? We are guaranteeing from low to mid minus 1. So that guarantee is also valid because mid minus 1 does not exist. So this is our initial setup. After we have initialized this way, we are going to run a loop for mid variable. Here is implementation of the Dutch national flag algorithm. We have a function sort that takes an array, and array should contain only 0, 1s and 2s, and n is the size of this array. We have initialized low as 0, high as n minus 1 and mid as 0 as we have discussed, right? Now we are running a loop while mid is smaller than or equal to high. So we are going to move mid and high. If you see these conditions, in every condition we are either moving mid ahead or we are moving high toward left side, right? So mid and high, they are moving toward each other, and when they cross each other we are going to come out of the loop. And we are maintaining this thing that elements from 0 to low minus 1 are 0, low to mid minus 1 are 1, and mid to high are unknown. Mid to high are the elements that we are currently traversing, and high plus 1 to n minus 1 are 2's. So what we do here is we check for array mid, right? Array mid is the element that we check all the time. If it is 0, then what we need to do is we need to increment the boundary of low, right? Low should move one position ahead and this element should go there. And whatever is at low, low must be, if this range is valid, then array low must be having a 1. So we move that one here and we move the 0 there. That way our boundary shifts, slides one position ahead, right? That's the idea we are following. And if there is no 1, then low and mid must be pointing to the same location, right? Then the same element will be swapped with itself, the 0 will be swapped itself, and your low will move one position ahead. Basically, you need to ensure that if you see a 0, your low window, this window, increases in size, right? Now, if you see this example, initially our low and mid are 0. When you see a 0 here, you are going to swap array low with array mid, and the same 0 is going to be swapped here itself, and your low and mid both are going to increment and both are going to become 1 now. So now you have a valid window of zeros, right? This window has now size 1. And now what you do is you again check what is array mid. Array mid is 1 this time. Now when you see an array mid 1, you need to increment this window. And how do you increment this window? You simply need to do mid plus plus. That will increment the size of this window. So in this case, we have nothing much to do. We are simply doing mid plus plus. So our mid now comes at 2. Right, and low stays here. You can notice that elements from 0 to low minus 1 are zeros and elements from low to mid minus 1 are 1s, and mid is currently here, right? So this is unknown range. And now what we do is we check for this element. This is now 2. So in case of 2, we need to increase size of this window, right? And how do we increase the size of this window? We move high toward the left side, right? So we do high minus minus in this case. Right, and and you need to ensure that whatever high currently holds, this value should be updated with 2. So what you do is you swap array high with array mid, right? And then when once you swap, you do not change mid because mid this element is unknown where high is currently pointing to, right? And this is swapped with a 2. This window is increased. We change high, but we do not change mid. So whatever was here is now going to be processed in the next iteration. So what we do here, we see a 2 here, right? Currently mid was here, we see a 2 here. So we are going to swap these two, right? This 2 is going to come here and this 2 is going to go there. We increase the size of this window by doing high minus minus. Now high is here and mid is here. We did not change mid because we do not know what is this current element, right? See, this window from high plus 1 to n minus 1 is guaranteed, not the high itself, right? So now we have 2 here and we have this window is guaranteed now, and now what we have here is we have 2 at mid. So again we fall into the same case, right? And we swap mid and high, right? So 1 comes here, 2 goes there. We do high minus minus. So high now comes here. Now mid is here. We check what is the current value of mid. Mid is 1. So we are going to increment it here. Now mid and high, they both are at this 1. Now we again check what is mid. Mid is 1. So we again increment mid, and mid now becomes 4. And now mid becomes 4. So mid and high, they cross each other. So we come out of the loop and our algorithm terminates. Let's now talk about time complexity and auxiliary space for this algorithm. See, auxiliary space is clearly theta 1 because we are not using an auxiliary array or list. Talking about the time complexity is theta n, and this algorithm requires only one traversal. See, in every iteration of this loop, you either increment mid or you decrement high, and you stop when they cross each other. So you are going to traverse through array exactly once, right? That's why the time complexity is clearly theta n, but theta n was earlier solution also. The great thing here is it's only one traversal.